In this video, we will use the Agilent 89600 VSA software with the SystemVue and ADS Ptolemy data flow simulators to visualize simulation results with just as much ease and accuracy as test and measurement results. There are actually two versions of the VSA software that can be used to anticipate system-level performance issues. One is the 89601BE, a reduced price configuration that's targeted for SystemVue and Ptolemy users, and the other is the full version, the 89601B, which also enables hardware connectivity and access to more standards such as LTE. The 89601BE simulation version of the VSA software is a reduced configuration comprising VSA options 200, 105, and AYA. By decoupling the VSA software from the test and measurement hardware, the software is free to float on an R&D network just like EDA software. Both users of SystemVue and ADS can co-simulate with the 89600 VSA software, and numeric data streams simply enter the VSA software as if they were test and measurement results. The user interface is exactly the same. Likewise, the VSA software is also capable of reading recorded waveforms in SDF format and piping those into SystemVue and ADS Ptolemy simulations as data sources for simulations. In both environments, both the source and the sink components are easily placed on a schematic. There are actually 6 key capabilities of the 89601BE VSA software that will add value to SystemVue and ADS users, going beyond the plotting capability in those platforms. The first is runtime tuning and animated displays of simulations that continue to run over time. In both SystemVue and ADS, sliders are available to allow lifelike interaction with simulation results, much like a test bench. In this SystemVue example, we have a pseudorandom source that frames data through a user-selectable modulation format. That data goes through a I and Q root raised cosine filter, is modulated onto a carrier, put through a compressing power amp, and then into an instance of the VSA software. When I hit simulate, you can see that the VSA software quickly responds and begins to calculate the results. What I'm going to do is arrange our screen so that I can see both softwares at the same time and interact with the sliders. As I change the gain, you can watch the EVM change on this 256 QAM signal. You can also watch the eye degrade and the spectral regrowth increase on the VSA measurement of the ACPR. As I ratchet down to 16 QAM, you will be able to watch the EVM drop and the eye and constellation improve. And if I drop down to QPSK, you can see the EVM drop even further. It's very easy to get an excellent idea of how this system is going to perform on a real test bench when you have interactive measurements like this. The second of the 6 capabilities was communications measurements that involved measurement bandwidths, ACPR, power between markers, occupied bandwidth. These are all dynamic measurements made on the fly by the VSA software. There are also several new trace types such as spectrogram, persistence, waterfalls, CCDFs, max and min, averaging, smoothing, gating. Many of these things, again, are possible with equations, but these are new dynamic trace types within the VSA software that add value to simulation users. There's also demodulation of 37 different modulation formats, as well as clock recovery, equalization, filtering, resampling, and a lot of other value-added signal processing that allows you to get true EVMs and constellations and eye diagrams. And with the number of algorithms that are involved in a sophisticated communications measurement, it's possible to directly compare between EDA results and test results because you're using the exact same algorithms. Finally, the VSA software itself comes with over 300 megabytes of SDF files in the help system. These help files are simply examples in the documentation, but they can be used by SystemVue and ADS users as incidental sources for interferers, specific modulation types, cross-modulation, and other non-critical applications. These 6 capabilities are all true of the reduced cost VSA configuration called the 89601BE. In addition, the 89601B has 3 additional capabilities. The first is the ability to connect directly to hardware with option 300. Whereas the simulation version allows you to visualize simulation results, the full version of the VSA allows direct control of the measurement hardware, allowing the same demodulation results to be presented for both simulation and measurement. With the waveform download capability of both ADS and SystemVue, it is possible to create and directly compare several different baseband and RF scenarios. Once again, the VSA simulation version allows waveforms to be brought in as a stimulus, but the full version of the VSA, the 89601B, allows the VSA to bring live waveforms into SystemVue and ADS for use in algorithm studies, realistic power amplifier testing, and so forth. The full version of the VSA also allows you to add 802.11ac, LTE Advanced, and other personalities, as well as custom OFDM, option BHF in the VSA software. Whereas SystemVue has an OFDM personality to make OFDM signals, the VSA software has a personality to demodulate them, and they are a natural pair. In this video, you've seen 2 versions of the 89600 VSA software. One, the 89601BE, a reduced price configuration expressly for ADS and SystemVue users, as well as the 89601B, the full hardware connectivity version. Both SystemVue and ADS Ptolemy users can use the VSA throughout the entire design cycle to anticipate system-level performance issues and begin design verification as early as the algorithmic phase. This is particularly important for modulated and complex envelope systems in both communications and defense. Please go to the following websites to request your evaluation: agilent.com/find ESOF-SystemVue-evaluation or ESOF-ADS-evaluation, or for the VSA software, agilent.com/find/89601BE. Thanks very much, and good luck in your next communication systems design.